Welcome guys, welcome to Tech Greens. So in the continuation to our series on Hadoop tutorial, today we'll look at what is Hadoop MapReduce, one of the most important concepts in Hadoop, a path-breaking programming model, how to perform processing of big data in the distributed way. MapReduce defines how data can be processed in a two-phase manner. So we'll discuss all this in this particular video. So let's start. So guys, what is MapReduce? MapReduce is a programming model and definitely an associated implementation of this model provided by Hadoop to do the processing of big data sets in the parallel not distributed way on the cluster of nodes. So it defines a programming model which is divided into two set of operations. One is the map operation and second is the reduce operation. Um, if you talk about MapReduce in the Hadoop world, it's a processing layer provided by Hadoop. So entire Hadoop framework is divided into two layers. One is your storage, provided in the form of Hdfs, and the processing layer is in the form of MapReduce. The whole idea of MapReduce programming model is designed to process large volumes of data, and this whole processing is performed in parallel, where the individual smaller tasks are processed across the different nodes in the cluster. So whenever you will submit any MapReduce job, that complete job would be divided into number of smaller tasks, and these tasks would be processed on the individual nodes in the cluster, and all tasks would be performed in parallel. And this whole concept of doing this parallel processing, which is distributed across the nodes of the cluster in the Hadoop world, makes MapReduce a powerful programming model to process the huge or big data sets. Let's try to look the pictorial representation of MapReduce. So whenever there's any client submit any MapReduce job, the first phase that will happen is the map phase. There would be different mappers running into the system. Ideally, there would be one mapper for each input split, or at a high level, you can say for each block. And then the output of mapper would go into the reducer, which will reduce the output of mapper based on a particular key, partition key, and eventually an output would be processed. And this the storage layer for this processing would be HDFS. So at a very high level, um, the map reduce is the combination of map phase and the reduce phase, and the combination of these two would produce the output. In simple terms, if we talk about MapReduce, helps to split the input data into a number of smaller parts, and then run the program on this partition data, and all this uh, processing happens in the parallel at once. The term, as we have discussed, is coined uh, based on the two operations which are performed in the MapReduce. One is the map operation. Whenever your client will submit any map reduce job, the input data would be taken by the mapper, and the individual elements in that data set would be broken down into the tuples, key value pairs, and once the processing is done, these key value pairs would go as an input to the reduce operation, and then reduce operation would combine these tuples based on the partition key, based on the key, and whatever the business logic would be provided, it will modify the value of the keys based on that particular logic. So in a nutshell, map phase will take the client input, break it down into uh, key value pair tuples, and those tuples go into reduce operation as an input, and then these are collated based on a key, or combined based on a key, and output is produced. Client program needs to put business logic in the MapReduce programming model. As part of the Hadoop MapReduce framework, there are a set of APIs, classes, and methods are provided. So you'll have to place your business logic in the same construct, and rest of the things behind the scene, how actually the task distribution or the parallel execution of tasks would happen across the nodes, would be taken care by the Hadoop framework itself. Um, One important point to note here, that in between the map and the reduce phase, there is a small phase called shuffle and sorting. So when the input from the mapper goes to the reducer, in between the data is shuffled across the required nodes based on the key. Like all the data for a particular partition key will go to the specific reducers, and sorting is performed so that the entire process execution can be optimized. Now let's try to understand MapReduce with an example. So here I have taken an example of word count. So if you see, this first box is an input. It's a text file with 3 records, and each 3 records are carrying different words. We're trying to find out the count of these words in this text file. So as it will go into the mapper phase, if you see, the first phase is the map phase. In this, the first thing which will happen is these records would be split and would be sent across to different nodes, right? So each individual record will go to the individual node. This is on node 1, this is on node 2, and this is on node 3, right? So this is how the input data is splitted, and the uh, partitions are created and sent across the nodes for processing. Then post split, the mapping would be performed. The mapping for the word count program is that we assign number 1 to each key. So my value of this data, the word value, becomes the key, and its count, and we assign number 1 as the value to that key, right? So my different keys in this system, in this particular examples, are the name of different animals. So we broke them down into words, the particular input, line input that is going to the mapper, and we assign 1 to each of the keys. So these are individual keys where we assign the 1. Similarly, the next record which is processed, so this is all happening, this all is happening on, say, node 1. Now this process will happen in node 2. So here the second partition, here the words are broken, and the key value pair, the tuples are created, where the key here is the name of the animal, and value v is assigned as part of the business logic as numeric 1. Similarly, this is node 3, how it is happening. So now this is the peripheral of the mapping phase. So behind this we have the map phase. In the map phase we had a split of the input records, and we did the mapping based on the business logic. Then these tuples, which are the output of the map phase, goes as an input to the reducer phase. This is my reducer. So the first thing which will happen here, we'll do the shuffling of the data based on the partitions key. So the tuples with the same key will go to the same node. Like if you see here, the key is same line, they all went to, say, node 1. Similarly, next key is tiger, it went to node 2. Similarly, elephant went to node 3, then node 4, node 5, and node 6. So they are shuffled based on the key, and this task of shuffling is performed by an component called partitioner. So partitioner is meant for performing shuffling and sorting. Uh, Later on in the videos, we'll see what exactly are these different components, partitioners, combiners, etc. But for a moment, shuffling is performed, which means the tuples with the same key are shuffled or moved to the same node, and then this reduce is performed on this, where we have taken the count, where we have combined these tuples based on this particular key, and the logic of combining says just do the addition of all the numbers uh, for all the keys. So we got, for this particular key, we got the count as 2. Similarly, reduce here got the count 2, here 2, here 1. There was only one key value pair tuple, so here we had 1. And eventually, reducer would emit the output. So output is emitted by the reducer. So this is our output, where we got the word count of this input text. This was the input, and this is our output. Here we got the word count for different words in the text sent as an input to the MapReduce program, right? So guys, this is, I think, a very clear example to understand how MapReduce works. And there, this is the entire life cycle how upon execution of MapReduce happens. So guys, that's it in this particular video. Have a great day. Thanks for watching. Bye bye.